So we are going to do the 3.3 examples. So our first problem is finding the measure of all of the labeled angles in the diagram. So we're going to find the measure of all 10 of these angles. So I'm going to write down measure equals. Make sure you put the letter M in front of the angle name because we're not dealing with the angle equals, it's measure of the angle is equal to. Now, it is not required in this particular problem, but as we go through, I am going to give the reason for each one. It's a really complicated picture, so we're actually going to break it down into much smaller pieces. So when we look at this, we have two parallel lines, and then in addition to those two parallel lines, we happen to have two transversal lines. So when I look at this picture, I'm going to break it down into smaller pieces. So the first thing I'm going to look at is the upper right-hand corner where I have the first parallel line and the vertical transversal. So at this particular location, we have a perpendicular indicator and angle 10. And we had a theorem in the last section, theorem 3.3, which said that we get 4 right angles when we have perpendicular lines, and right angles are 90 degrees. The next set that I'm going to look at is that same parallel line with the second transversal, and at this location we have angles 1, 2, 3, and 42 degrees. Now, this does not use our new information. This is our information from chapters 1 and 2 with vertical angles and linear pairs. So remember that vertical angles are congruent. So the ones that are across from each other within the X are congruent. So I can get angle 2 using my vertical angles theorem. And then I'm going to use something else to find angle 1. And then I'm going to use the vertical angles theorem to fill in angle 3 once I know angle 1. So angle 2 is the same as 42 degrees. Now to find angle 1 and that 42 degrees are on a line, and they are a pair to create that line. So we're going to use the linear pair postulate. So the linear pair postulate says that they are supplementary. Supplementary means that the sum of the measures is equal to 180. So when I subtract 42 from 180, we get 138 degrees. And by vertical angles theorem, angle 3 is also 138 degrees. Now what I'm going to do is I'm going to look at my two parallel lines and the two different transversals. So I'm going to look at my parallel lines with the vertical transversal, and I'm going to look at my parallel lines with the slanted transversal. So in the first one, my parallel lines with the vertical transversal, we create the box in angle 10, and then in my bottom parallel, my vertical transversal and the parallel have angle 8 and 5. So we already know angle 10, and we have our new theorem, the perpendicular transversal theorem, which means that we're also perpendicular to the other parallel, and then we can use our theorem 3.3. So since we're perpendicular, our theorem 3.3 that we create 4 right angles to get that angles 8 and 5 are 90 degrees. In the other transversal, we have the 42 degree angle. We've already found angles 1, 2, and 3, and then that transversal with our second grouping makes angles 4 and 7. So angle 4 with the 42 degrees are both on the left side of the transversal, and they are both above their parallel. So angle 4 and the 42 degrees are corresponding angles, and we have a postulate that says that they're going to be congruent. So angle 4 is 42 degrees. And then our angle 7 and that 42 degrees are on alternate sides of the transversal and in the exterior. So we have our alternate exterior angle position, and we have a theorem that says that those are congruent. So angle 7 is also 42 degrees. Our most complicated set of angles that we're going to have to find are 6 and 9 because they're created with the transversals. And if I just look at the transversal, I have angle 6 and 9 with no additional number information. So I'm going to have to put in the parallel line. And we know that angle 5 is 90 degrees, so that's a perpendicular. And we know that angle 7 is 42 degrees. So we can actually now find the information. Angles 6 and 9 form a pair of vertical angles. So they're going to be congruent to each other. So I'm going to find angle 6 and then use the vertical angles theorem to automatically fill in angle 9. And for angle 6, we're actually going to use something from 3.2. We have adjacent acute angles with a perpendicular set of sides. So we're going to use theorem 3.2 from our last section that says that they are complementary. So the measure of angle 6 plus 42 degrees is going to equal 90. And when we solve, we get 48 degrees. And by vertical angles theorem, 9 is also 48 degrees. And we have now calculated all 10 of those angles. In the next set of problems, we have two parallel lines with a transversal. I always go through and I like to highlight the transversal, and I also like to highlight the interior. I find it easier to identify the angle positions if I highlight the interior and the transversal. So we're going to use our angle positions. In the first question, our x value and the 83 use the same parallel line and the transversal. So they happen to be a linear pair. So we're going to use the linear pair postulate, which says that they're supplementary. And by definition, supplementary, the sum of their measures is 180. So x plus 83 equals 180, and our x is equal to 97. Then when we look at our y value, y is on the exterior, and on the right side of our transversal, our 83 is on the exterior and the left side of the transversal. So we can use our alternate exterior angle theorem that says they're congruent. So we set their measurements equal. 83 equals y minus 13. So 96 is the value of y. In problem 4, our value of x and the 98 combine to make our first of the parallel lines. So once again, we're going to use the linear pair postulate. So the x plus 9 plus the 98 will have to equal 180. So x plus 107 will be 180, and our x is going to be 73. Now, there's two ways we can find the measure of angle y, but without having to move anything, we're going to use our fact that the x plus 9 and the y 2y are in the same position. They're both above the transversal and they are both to the right of the parallel line, and use corresponding angles. And we have a postulate that says they're going to be congruent, and we're going to do a bit of substitution. So we're going to set them equal, but I'm going to fill in the 73 for x. So I have 73 plus 9 is going to equal 2y. So this is 84 equals 2y, and 41 for the value of y. In problem 5, we have a perpendicular transversal, and we happen to have a perpendicular transversal theorem. So we're perpendicular at both parallel lines. And then we have theorem 3.3, which says we get 4 right angles. And we use our definition of right angle to get that they're 90 degrees. So every angle in this picture is 90 degrees. So our x plus 25 is 90 degrees, and our y minus 18 is 90 degrees. So our x is equal to 65, and our y is equal to 108. In our next set of problems, we only have one variable, and we're going to use our parallel line information. So once again, I like to go through and my transversal, I like to highlight that. So it's easier to tell if they are on the same side or alternate sides. And I also like to highlight the interior, so it makes it easier to identify angle position. So this is a matter of identifying the angle position, using our rule for that position to write an equation, and then solving the equation. So in problem 6, we have two angle measures. They both happen to be on the left side of their parallel line, and they both happen to be above the transversal. So we're going to use our corresponding angles postulate and set them equal. So 6x minus 32 equals 148. So 6x is 180, and x equals 30. In the next one, the 84 and the 7 times the quantity are exterior angles. One's on the left and one's on the right, so these are alternate exterior angles, and we have a theorem that says they're congruent. So we're going to set our 7 quantity x minus 19 equal to 84. So this is 7x minus 133 equals 84. 7x equals 217, and x is equal to 31. In problem 8, both of our angles are in the interior, and both of our angles are on the right side of the transversal. So this is consecutive interior angles theorem, which says that they're going to be supplementary, which says that my sum is going to be 180 degrees. So we're going to take the 5x minus 25, we're going to add the 3x plus 9 and set it equal to 180. So this is 8x minus 16 when we combine the like terms. 8x is 196, and our x is 24.5. And yes, it's okay to get a variable value that is a decimal. So identify the angle position, use the theorem or postulate rule for that angle position to write your equation, and then once you have your equation, solve for the variable. Our last example problem is writing a proof, and the key to this is they tell you which theorem we're proving. So we cannot use this theorem as a reason. So we're not allowed to use the alternate exterior angles theorem as a reason because we're proving that theorem. So I'm going to make 2 columns, one for the statements and one for the reasons. And whatever reason 1 goes with statement 1, so our matching statement with its reason. Remember that everyone should be able to fill in 3 pieces because we should start with our given information. So we have been given that for this picture, line L is parallel to line M. So that is true information for this picture. And then we are also told what we're trying to prove. And remember that what we're trying to prove should always be our last statement. So whatever it is that we're trying to prove is our last statement. So we're trying to prove that angle 1 is congruent to angle 2, and we're trying to do this with the without using the alternate exterior angles, because if we look, yes, angles 1 and 2 are alternate exterior angles, and yes, that theorem does say that they're congruent, but that's what we're trying to prove. So they gave us parallel, but they also gave us an angle 3. So we're going to use that angle 3 to help us prove information about 1 and 2. So when I look at my picture, we have our transversal, and within the transversal, we have that angle 1 and angle 3 are both on the right side of the transversal, and they are both above their parallel line. So just like we did in problem 6 above, we can apply our corresponding angles postulate. Our corresponding angles postulate says that these 2 angles should be congruent. So angle 1 should be congruent to angle 3. And notice that we now have the angle 1 from what we're trying to prove. That's all I can get with my parallel lines, but if I look at the picture at the section with angles 2 and 3, I can get some information here. So 1 and 3 were corresponding angles, and it turns out that angles 2 and 3 are vertical angles. And we have a theorem. So these are vertical angles, and we can now use the vertical angles theorem. According to the vertical angles theorem, those angles are congruent. So angle 2 is congruent to angle 3. So now we have our angle 2 from what we're trying to prove, and they are both congruent to angle 3. So since they are both congruent to the same angle 3, we can use the transitive property to say that they are congruent to each other. And we have just proven the alternate exterior angles theorem.